Hello friends, आपको नमस्ते. So today in this video we will use face recognition library, and we do using this library we will do following function: detecting face, draw bounding boxes on the faces, detect facial landmarks, generate face encoding, compare two faces, recognizing people, means recognize people in unknown images. Okay, how we can do that? All this functionality we will explore. So let's get started. So this is a, you can say this is a library which is required. The main thing is that we import face recognition library. Okay, first thing is that helper function to display images. This is a function which is required to display the images. Here just we give the image, then the title of the image, then the figure, size will be 6.6, then we show access will be off, title will be this one, and this will be show the image. Now load an image. We first load the image. This image will be used for face detection, landmarks, and encoding. Okay, throughout all this code, this face image will not change. Okay, so for that we use the face recognition dot load image file and just give your image. This is your Cristiano Ronaldo image which we are using. Okay, after that we just show that image using this function. We show that image. So this way this image is shown. Now face detection, we want to detect face in this particular image. How we can do that? Using a face recognition library, we just have to use face recognition dot face location. It's find the location of the face in that particular image. I just pass the image, you will get the face location. After face location, let me print it will give me this values. It will be the bounding box coordinates value it give me. Now let me show you. See, first number of face detected. It when I print the length of face detection means only one face is detected, and just printed face location. I just printed here. It give me the bounding box details. So how we can do that? Draw the bounding box over the face. So just to we first make the copy of the image, then we will iterate on the face location. Okay, and then we just get this top right bottom left coordinates values. These are the you can say top right means. At the top left corner bounding box coordinates value, and this is bottom right corner coordinates value. So this will be just plot the image. This is a color and this is the thickness of that. Okay, so this way we just after calling this show function, our image will be there with face detection bounding box around it. Okay, now we have to do facial landmark. How we detect the facial landmark on the image using a face recognition library. So how we can do that? We just use, I want to detect eyes, nose, lips, and jawline. How we can detect that? Just use face recognition. Just you have to use face recognition dot face landmark. Just pass the image and your landmarks will be ready. Let me print the landmarks. So these are the coordinates values: left eye coordinate value, right eye, mouse bridge, mouse tip, left eye. So these are the coordinates value. So how we can plot this? This is a chin coordinates value. Till here, this is a chin coordinates value. So how we can plot that? It's just the first we make the image copy, then we'll move iterate over the landmarks, face landmarks. After that, we iterate over this face landmark dot values. Okay, after getting this feature points. Okay, after that we loop over the feature points. I will get the points and we draw the points here. What is that we are looping again and again? Let me explain you. Face landmarks. Okay, for better explanation, let me print. Okay, face landmark here. What it show me? Okay, then I want to apply here. Okay, print feature points. Then I want to print point, and then I want to apply. I want to iterate over just for one iteration. So here, okay, for that this is break for this for loop. Now this is break for this for loop, and then this is break for this for loop. Okay, now let me run it. See, face landmarks give me chin landmarks coordinates value. After that I want to iterate over it. So that's why I face landmark dot values, I will iterate over these values. As you can see, 146, 137. So after this I want to iterate over this list. So how we can do that? Just feature points, then point, then I will get 146, 27. So this is the way we are iterating, how we are fetching the coordinates values. Okay, so don't get confused what is happening here. Now let me remove this breaks, no required now. Now let me run it. So these are the landmarks. After getting the landmark, we just do CO2. After getting the points, we will do here we just give the points and on which image we image landmarks. This is say the radius. This is a color and -1. We want to draw this means we want to fill that particular circle. So this way we drew that. Okay. After getting, we draw the landmarks using a face recognition library. Now, what is this face encoding? Okay, what is face encoding? Each face is converted into 128 dimensional vector. Okay, this is the heart of the face recognition. Matching faces for means by using encoding, we use face matching faces, identify people, and storing face identities. So face recognition or face encoding just pass the image. Your face will be encoded in 128 dimensional vector. Better if I would use length encoding 0. Okay, suppose I will do this line encoding only and just print it. So it's give me total encoding 1 because in particular image it's detect only one face. Okay, if suppose I want to know see this 0 and length of that particular encoding of one face, its length will be 128, means my entire face is encoded in 128 dimensional vectors. Okay, how we can use this in face similarity? How we can do that? So for that, this are these two images of the same person. How we can know that? It's compare faces. We use compare faces and facial distance similarity score and true or false. Okay, suppose we load the image. This is a Cristiano image and this is a okay, so this is Cristiano Ronaldo image and this again one image. Oh sorry, this one, not this one. Okay, these are two images of same person. So I just load them in the images. After that, we encoded them in this encoded one and encoded it. I want to know the comparability, means whether those two persons are same or not. Just true and false value I want. So this way we use compare faces. It's give me result. If I want to know the distance between those two faces, how much similarity between them, so it's give me this distance value, give me that value. Okay, so what's smaller value means more similar faces. Okay, after that we just print the result and the distance. Okay, so how it's working? Suppose though two faces of similar person, it give me same person means result give me same person. Yes, those two persons are same. Similarity score will be 0.3, means near to 0. It means you can say that those two person are 30% on 30% more, sorry, 70% similar to that particular person. So now let me show you one image with some messy one now. Okay, now let me run it. It's give me similarity will be false and score will be greater than 0.7%, means 30% similarity is there but not and not that much similarity there. Now we want to and identify. Suppose we want we have passed two images to and we have generated encoded and want to that we pass the unknown images in that particular images multiple faces are present and want to find that particular person is there or not. Okay, so how we can do that? See, create a database of known faces, detect face in unknown images, compare each detect faces with the database, write the person name on the image. How we can do that? All these things. Suppose I want to know the known faces, so we load those known faces. That is Cristiano Ronaldo, Messi, and Neymar. So these are the images: Cristiano Ronaldo, Messi, and Neymar. Okay, after loading them, we also create a known name Ronaldo, Messi, and Neymar. After that, we generate the encoding for each face. How we can do that? Just use for loop for img in known images. Okay, in known images, we loading after known it. We just use the encoding here. After that, all encoding for particular image is stored in this list non encoding. After that, we give one image which is have multiple faces. For example, I'm using this time. I'm using this group which have only all three faces as represented. So how we can just pass this particular image, then it will detect face location will detect faces in that particular image. Right now it will detect three faces. Okay, after detecting three faces, generate face encoding for each detected faces. How we can do that? Just pass face recognition, face encoding, and unknown location. Both thing you have to pass. It will generate the unknown encoding of all three faces, encoding separately. All three faces separately encoding will be there. Okay, for example, let me show you what is happening so that you will not get confused. Let me print the length of this unknown encoding. Okay, let me run it. String time, please wait. Okay, it's not showing me the length. Oh, so you're saying showing the length 3. See, this is 3 length, means 3 faces detecting and fees 3 encoding is present, or unknown encoding is present. Okay, now after that we just make the copy of that particular image. After that we zip over the, see what is happening. Let me do it here. We zip over unknown encoding. Okay, so this is unknown encoding of 3 faces. Okay, each 3 faces, and this is unknown location of those faces, which is stored in this variable. We loop over it. When unknown encoding give me encoding for particular image, and this unknown location give me that location of that particular face, or an encoding means that particular face encoding will be there, and but that particular face bounding box it will give me there, if I am talking about the first iteration only. It will, in face recognition, compare faces will match that particular encoding to the non-encoding, this encoding where 3 known faces encoding are present. Okay, it will compare that. If initially name will be unknown, if true in matches. Okay, let me print matches here. Oh, sorry, first okay, let me print matches. What is matches? Okay, and let me break it. Only single iteration will be there. Okay, false, true, false, messy means first first encoding is of messy. It's in the get the bounding box of detail. It compare that encoding with the non-encoding, and you can see that second one will get true here. Okay, it means if it is true, if true in matches, true in that particular matches list. Okay, it will move down to the if statement, and if after that we get the index of that. After getting the index we can easily know, get the known names. From known name we get the name of that particular encoding which is matched. After that we just draw the rectangle and the text. If it is not matched about in all 3 encoding, it will be unknown, and here name will get unknown here. So this way we are working here. We get we just compare that known name, known face with the in the unknown images. Okay, so let me run it again. This is Ronaldo, Messi, and Neymar. Now let me take one different image. Let me take one image. Okay, it's working. Messi and Ronaldo, perfect. Now let me take uh, 3. Okay, Neymar and Ronaldo. It's working very well. Okay, so this way we use face recognition in multiple ways. Okay, hope I have given some knowledge to you. If you like my video, please like, share, and subscribe my video. Thanks to all.